relationship to turns and voltage ratio is what? Inverse. Inverse to voltage and turns. I'm just going to write V/T, voltage turn ratio. Inverse. So simply put, this transformer right here has a 2-to-1 ratio. When you actually see it on a schematic, and it states like this, 2-to-1, it's talking about this. It's not describing this, it's describing the turns and voltage ratio since they're the same. So that being the case, the current ratio is what? 1-to-2. All you gotta do, hey, it's inverse. Oh, just flip it around. Current ratio would be 1-to-2. That's how simple that can be. But it's one of those things that you could get what? You can get got if you're not paying attention. Pay attention and understand what the question's asking of you. Pay attention. What are some uses of a transformer? How about step up, step down? Yes. Step up, step down what? Yeah, voltage. Don't forget about that transformer outside this building. That gray cylinder that's hanging on that pole out there is a couple hundred volts, like 369, 370, give or take. Once it hits there, the energy that is, that's being transmitted to it. But by the time the action takes place of, which one? Step down, we end up with basically 120 volts AC here. That is a what?
31 transformer.
Well, standard. Sure, standard. That's not the point. 120 volts, give or take, 119, whatever. It's a standard. It's a standard, isn't it? It's a standard. Well, all right then. Riley, go ahead. What else?
Separating DC voltage.
How about isolate? Isolate DC. Yeah, that's another use. When we get to next Annex B03, we will talk about coupling. One of those types of coupling is called transformer coupling. We can use there's one that's missing, step up, step down, or what other type of transformer? We can use a unity transformer to do that. Okay. The next question on the board here, self-regulating device, a transformer is why? Why is a transformer a self-regulating device or considered that? Yeah, that's basically what it is. Compensates for changes in load. Very down Barney style definition. It's self-regulating. We're going to go up here and we're going to do some calculations and remind everyone that, oh yeah, it is. Because you can't argue with the what? Yeah, the math and ratios. What or who makes that shit up right there? Well, the manufacturer creates the transformer, but as far as that goes, that's physics. Isn't it? It is. It really is. It's physics. That boils down to this. Because that changing signal being applied to a coil, now the manufacturer sets the number of turns. Okay, good. But based on the number of turns on the primary and secondary directly relate to this, therefore inversely relate to that. So we can't argue the ratios because that's physics. It is what it is, what it is, as far as that goes. Taps. You need to understand, write it right here, tap on a transformer. What's the deal with that? Yeah, you can use it to divide up the voltage, primary and secondary. We're only going to look at it from the secondary perspective here, as far as calculations go. But here's the thing you need to remember. Taps can be placed anywhere along any winding, meaning primary or secondary, that's what it means. So for example, here's one. Should be simple enough, because we'll do a couple of these and then ready to go. 50 volts AC, here's my source on a primary, and I'm giving you a ratio of 1 to 20. First off, what type of transformer is it? Step up, because we know if the secondary number is larger than the primary in the ratio, it must be a step up, or if it's flipped around, it'll be step down. Good. So you could use common sense logic to determine what is being induced over to the secondary, or you could actually use a formula. If I want to know the secondary voltage, because that's what it is, we're basically trying to find, this is the formula, isn't it? Yeah, it's the primary voltage, because you just basically manipulated the ratio, primary voltage, which is this, and multiply that by the number of turns on the secondary, the number of turns on the primary, and that's where these numbers go in this formula. So realizing that, oh, it's probably, we know it's a step up, it's probably 50 times 20, right? Yeah. So what is the secondary voltage? 1 secondary voltage equals 1 kilovolt. Now, notice I have a tap, and I've got 75% here. So basically from the tap down to the bottom, 75%. What's up here? 25%. Well, in order to figure this out, it's probably a good idea to find out what the whole secondary is worth, and then multiply that secondary potential times the percentage of what you're being asked. And what am I going to ask you? Hey, what's the potential from the point here in this tap to the bottom of the transformer, the bottom of the secondary? 750 volts. Is that difficult? What's up here? Yeah. Because what's additive in series? Because this is basically a loop in series. What is it? Yeah. So can't I use that as like a voltage divider too? Yeah, you can. You ever understand how to calculate for a tap in a transformer? Can you do it? So step 1, find out what the secondary is. Step 2, take the total secondary and just multiply by whatever percentage you're being asked for. Answer, done. You make it real easy, just like that. All right, so back to here, the current ratio, because this has to do with the current ratio. I've got another transformer here. I have 60 volts AC, and then I've got 6 volts on the secondary. So 60 on the primary, 6 on the secondary. What's the current ratio?
What it's in.
Ha ha ha! See? Gotta pay attention.
Oh, you got it.
Yeah, I did that on purpose too. So it's better to get you now than tomorrow, right? Yeah, you don't want to get God on that because you're not thinking about the inverse relationship. Because you're real quick to say 10 to 1, right? Because that's what this is. But the current ratio, since it's inverse, is 1 to 10. You flip it around. See how it's like a two-parter? Yeah, so pay attention to that. Because I don't have to give you the actual ratio itself, because that's easy. If you're given a ratio, I do flip it around. But what if you're given the actual voltages? Oh yeah, because you can get the ratio, voltage ratio, turns ratio from this, right? So you can say, oh, that's an easy one, it's common sense, 10 to 1. But to get that is what I'm asking you for, 1 to 10. One last thing we need to do here. The top one right here. 2 to 1, 20 volts AC. To solve, because now I've got a load here, 2K ohm load, to solve these things, here are the formulas, parameters that we need. So first thing we have to do is find the what? Secondary voltage. So if I've got a 2 to 1 ratio, we know it's a what kind of transformer? Step down, because this number's smaller, the secondary. So applying the formula, or common sense, because that's the formula, what's the secondary voltage? 10. Does that make sense?
Yes, sir.
Okay? Because basically we're taking, there's number of turns on the secondary, 1 over 2 or half of 20. Make sense?
Yes, sir.
Okay. So we'll write that.